Welcome to Math with EJD. In this video, we're looking at Laplace transform of piecewise functions. So as the name implies, right, you have a function that is piecewise. So the Laplace transform of piecewise functions involves using the Heaviside step function. I think we've done something close to this when we talked about unit step function. Using the Heaviside step function, which we can refer to as UC of t, U sub c of t, right? Which is defined as UC of t equals 0 when t is less than c, and 1 when t is greater than or equal to c. So it's that kind of switching thing we talked about previously. Okay, so this helps express piecewise functions in a single equation. So piecewise functions actually have different values. They're more like step functions, but with Laplace transform, right? With this expression, right, we can have it in one equation. And so once we can write it in one equation, it makes it easier, making it easier to apply the Laplace transform. Okay, now let's look at general approach to this. General approach. So the first thing is you express the piecewise function in terms of Heaviside functions. Heaviside functions, that kind of switching function rather. Then number two, use the shifted function transformation. Shifted function transformation. So, and that is what we've seen the type before. You have the Laplace of f of t minus c, uc of t, and that is simply e raised power minus the shifting cs multiplied by the Laplace of f of t, right? Whatever f of t is. So you have this kind of thing right there. Okay, so where f of s is the Laplace transform, of f of t assuming t is greater than or equal to c, like that. So let's take an example. Example 1, find the Laplace transform of f of t, which is t for 0 less than or equal to t less than 2, and it's 4 for t greater than or equal to 2. So step 1, so we have to rewrite using Heaviside functions. So here we need to know that the function can be rewritten as f of t equals t u naught of t plus 4 minus t u2 of t. Okay, now look at what we have up there so you can understand the relationship. So f of t is this t now, then our we have uc of t, right? Uc of the time. So we have u, the c here, the delay here is 0 for this one. So we have uc 0 of t like that. Then for the second one, we now have 4 minus t. So for this 4 minus t now, no, okay, this is okay because t is already out, so we have 4 minus t, and then that will be for u2 of t. So that's how to write that based on what we have up there. So we have the t, and then we have, since t is taken out, then we now have 4 minus that t. Okay, so once this has been written this way, we can go for step 2, where we apply Laplace transform. Step 2, apply the Laplace transform, or apply Laplace transform. So to that Heaviside thing now, so we basically have um of course, using known transforms, right? We need we know that the Laplace of t is normally 1 over s squared, and the basis of that is this, because of that t we have up there, right? So the second one is now this is 1 over s squared u naught of t, right? So we now say for 4 minus t u2 of t, use the shift property. And what does the shift property teach us? It tells us that the Laplace of 4 minus t minus 2, 4 minus t minus 2 u2 of t will just give us, if I can bring it down, in fact, so this will just give us, because of the shift of 2, we have e raised to minus 2s settled. Then we now have the Laplace of 4 minus t minus 2, following this now, 4 minus t minus 2. And if we do 4 minus t minus 2, this is simply, this is e raised by minus 2s. The Laplace of 4 minus 2 is 2, so we have 2 minus t, basically. So, and from there we have e raised by minus 2s. Then the Laplace of 2 minus t. The Laplace of 2 is basically 2 all over s, Then the Laplace of t is 1 all over s squared. So we have this into all this. And with that in place now, we can then have the overall thing. Okay, so overall, the Laplace of f of t, which we can call our f of s now, is actually the Laplace of the overall thing, which is t u naught of t u naught of t plus 4 minus t u2 of t, 4 minus t u2 of t. So this 2 now is the shift, and that is why for t minus t, so the shift here is 0, so that's why we just take t directly. So this is simply 1 over s squared plus e raised to minus 2s into 4 over, not 4 over s, now 2 over s minus 1 over s squared. Okay, 2 over s minus 1 over s squared. So we can just say, thus for f of t for f of t equals t 0 less than or equal to t less than 2, and for t greater than or equal to 2, we have fs to be what we got up there. That is 1 over s squared plus e raised power minus 2s into 2 over s into 2 over s minus 1 over s squared. That's what we have. Okay, now let's take another example. So shift this here and then we go for this. Let me do this. All right, so example 2, we have to find the Laplace of g of t, which is 0 when 0 is less than or equal to t less than 3, and then it's t squared when t is greater than or equal to 3. So in that case, we go for step 1. Step 1, we write using Heaviside. And if we do that, it just tells us that g of t equals, here, the first one is 0. So normally it should be 0. Let me just do it for the sake of it. So the first one is 0, right? So it should be 0 u0 of t. Then plus, then at the next level, right? 3 seconds have passed, or 3 time units have passed. So we just have, in that case, t minus 3. And because this t is squared now, so we have t minus 3 squared. I mean, t minus 3 squared, right? Because 3 time steps have passed, then u3 of t. But of course, this is 0, so it just goes away. So we know that the proper g of t is actually t minus 3 squared u3 of t. So this is that same expression in Heaviside form. And now that we have it in Heaviside form, it's now easy to integrate. I mean, to apply Laplace. So step 2, apply Laplace transform. Apply Laplace transform. Okay. So to apply Laplace transform, now we just have the Laplace of t minus 3 squared u3 of t. Okay, I mean, this is a format we are used to. So it will just be the shift e raised power minus 3s, then the Laplace of the f of t, which is t squared now. So, and that is e raised power minus 3s. Then the Laplace of t squared is simply the Laplace of t squared will just be 2 all over s3. Okay, that is simply 2 e raised power minus 3s all over s raised power 3. So for g of t equals 0, 0 less than or equal to t less than 3, and t squared, which is t greater than or equal to 3, okay, we have, because when you take the Laplace of g of t, you get something like g of s. So g of s is simply 2 e raised power minus 3s all over s cubed. Of course, you can also write it as e raised power minus 3s, okay. I mean, let's leave it that way. There's no point belaboring that. But I mean, the deal is the deal. So with that now, by rewriting piecewise functions with either step functions, we can efficiently compute the Laplace transform using the shift theorem and known transforms. So let's take some practice questions. So practice, compute the Laplace transform of the following. Compute the Laplace transform of the following piecewise functions. Okay. Excuse me, number 1, f of t is 3, 0 less than or equal to t less than 2. So after 2 time steps, now have 5 into t greater than or equal to 2. That's one. Number two, we have g of t equals step function t, 0 less than or equal to t less than 4, and 2t is t greater than or equal to 4. Then we have 3, h of t is 0, then 0 less than or equal to t less than 3. So that's 6 minus t. So the other one is 6 minus t, 6 minus t, t greater than or equal to 3. Number four, f of t is now t squared, 0 less than or equal to t less than 1, then 1 for 1 less than or equal to t less than 2, and t finally for t greater than or equal to 2. So that's a bit more complicated. 5, you have g of t equals sine t for 0 less than or equal to t less than pi. And then we have 0 for t greater than or equal to pi. Then number 6, you have f of t equals e raised power t, 0 less than or equal to t less than 2. Then e raised power 2t, and t greater than or equal to 2. Then number 7, g of t equals 0 for 0 less than or equal to t less than 3, and t minus 3 cube, and that's t greater than or equal to 3. Then number 8, finally, number 8, we have h of t equals cos t, 0 less than or equal to t less than 5, and we have e raised power minus t, t greater than or equal to 5. All right, let me see your answer in the comment section, either on YouTube or on Facebook. And don't also forget to let me know how helpful these videos are for you. And if there's a topic you'd like me to teach or a problem you'd like me to solve, for those who have subscribed to this channel, thank you so much. If you have not subscribed, you want to do that right away, because you don't want to miss the other things coming your way, or the things that are already on this channel already for you. A lot of videos, so many, like approaching 700 already. So you don't want to miss out on any of that. Apart from that, you want to also share, so hit the notification bell so you can always get alerted each time a new video is released. Then share and like and share, so that more people can have access to this great content. Till I come your way again, keep doing maths right. Bye.